In fact, there's 4 patterns that you can follow that require only 3 pair of corresponding pieces to be congruent, and it's a guarantee that the entire triangles will be congruent if those 3 pair are. So here's the 4 congruence patterns that work. SSS and SAS. The S's stand for sides and the angle, or the A stands for angle. These are the patterns that involve 2 pair of sides being congruent. And then the bottom ones, ASA and AAS, angle side angle and angle angle side. These involve 2 pair of angles being congruent. Okay, so let's take a look at how you can use the shortcuts for these. Again, we'll start with side, side, side. If we have 2 triangles, and we'll call them ABC and DEF, and let's say the tick marks on these line up in such a way that you have 3 pairs of sides that are congruent to each other. Again, they don't have to be oriented in the same direction. Okay? As long as you have those sides, then you know you're dealing with congruent triangles. So 3 pair of sides congruent is all you need to show that the triangles themselves are. Okay? So we have that pattern met in this case. And so we can write a congruent statement for this. Triangle ABC is congruent to, again, the first statement, first part of the statement can be arbitrary. The second part has to map directly to the corresponding pieces. So A is opposite 2 tick marks, so which side does, or which angle does that correspond to on the other triangle? Opposite 2 tick marks is F. B is opposite 3 tick marks, it corresponds to D. And then finally C is opposite 1 tick mark, it corresponds to E. So this would be our congruent statement, and our pattern, the justification, would be SSS. Okay, so all you need is 3 pair of corresponding pieces, and that's enough to show that the entire triangles are congruent. Okay, let's look at the next pattern, side angle side. So if you have 2 sides and the included angle between those sides, or 2 pair of sides and the included angle pair between those that are congruent, that's enough to show that the triangles themselves are congruent. So let's say we take something like this. Okay, so if we look at this triangle, we have 1 pair of sides that are given as being equal. We have this right angle. Well, what's the linear pair of a 90-degree angle is what? Also 90. So we have this pair of angles. And then is there anything else in this triangle, in this diagram, that you know is equivalent in the 2 triangles? This third side of each triangle is equal to itself, right? So here's a case where reflexive property comes into play. So we know that JH is equal to itself. GJ and JI are equal, and then these 90-degree angles, all right angles, are equal. So we have a pattern of 2 sides in the included angle that fits this pattern of SAS. So that's all that we need to know, and this guarantees we have congruence of triangles. So we can write our statement. Again, you can write it in alphabetical order, GHJ, but it doesn't have to be. You could pick any arbitrary order for those. However, the second part of the statement does have to map onto it. So G is opposite the 2 tick marks, so it corresponds to what point or what vertex in the other triangle? Opposite the 2 tick marks is I. H is opposite the 1 tick mark, it corresponds to H is also opposite the 1 tick mark in the other triangle. And J is the right angle, it corresponds to J, the right angle in the other triangle. So here's our congruent statement. And we can justify it by 2 sides in the included angle, SAS. All right, those are the 2 triangle congruence patterns that involve at least 2 pair of sides. The last pair here involve at least two pair of angles. The first is ASA, so angle, side angle. If you have two pair of angles that are congruent plus the included side between them are congruent as well, then the entire triangles are. So let's say we start with this information right here. All right, so if you have these two triangles formed by the intersection of lines, you're given this pair of sides, KM and MO, as being equal, and then you're told that KL and NO are parallel to each other. And now we could use either of these patterns here based on this information, but let's see if we can use ASA. Okay, so what do I know about angle K? Angle K is equivalent to which other angle? Since these lines are parallel, what do you know about alternate interior angles? They'll be equal. So angle O and angle K are equal to each other. And like I said, if we wanted to use one of the other patterns, we could have said N and L are also equal here based on that same reason. But let's say I want to do a pattern of ASA. Can we make the statement that these two angles are equal? What kind of angles are those? Vertical angles. So vertical angles are equal, therefore we have this pair of angles the same as well. So when we look at the whole set of triangles, the pair of triangles, we have two pair of angles that are equal plus the included side. That is our pattern ASA. Okay, so we can write the statement that triangle KLM is congruent to triangle, and then we map on the corresponding pieces. So K is the angle with one tick mark, so it corresponds to O. L is the angle with no tick marks, so it corresponds to N. M is the angle with the two tick marks, so it corresponds to N. So here's our congruent statement, and the pattern that's fulfilled is two angles and the side included between them, so ASA. All right, the last pattern is two angles and the non-included side. So angle, angle, side. So if we come back to a diagram that looks like this, okay, so if we're given this information here, would there be enough information to demonstrate that these two triangles are congruent to each other? We have this pair of angles P and R equal. We have this right angle QSP. What's the linear pair of a right angle? Also 90 degrees, or right angle. So here's our second pair of angles. And then do we have a side between these two triangles that is congruent as well? Yeah, this shared side, right? So angle Q or angle P and angle R are both opposite this shared side, QS. Okay, so reflexive property states that QS is equivalent to QS. So we now have two angles and a non-included side. That's this final pattern. So we can make the statement that triangle PQS is congruent to triangle P is the angle with one tick mark, corresponds to R. Q is the angle with no markings, so it corresponds to Q. And finally, S is the right angle, it corresponds to S. So the pattern fulfilled here is two angles, the non-included side, so AAS. Now, there's another relationship that we could have identified here. Let's say we didn't want to use this relationship. If we look at the entire triangle PQR, what do we know if the base angles here, P and R, are equal to each other? What do we know about the sides opposite those? They'll also be equal, right? So what that would mean is that in this large triangle, so the whole triangle, not each individual one, but if angle P and angle R are equal, then that means the sides opposite them would also be equal. So we could have used our markings here to show, and we still would have found congruence of triangles using two angles and the non-included side, so it still would have been the same justification, AAS.